Yeah, hi. Good morning.
Okay, so let me quickly start sharing my screen. So we'll jump into our today's discussion. Before that, hope everybody practiced that use case. Anybody have any issues? Anybody facing issues?
No,
Okay, okay, fine. So let's proceed to our today's discussion. So okay, so let's recap what we have discussed, right? So till now we have discussed lot many things, and we have seen a few services in GCP as well, right? So let me quickly recap what we have discussed. So we know the object storage file system in Google Cloud Platform, which is GCS, Google Cloud Storage. So we know how to upload files into Google Cloud Storage. We know how to ingest files into Google Cloud Storage, right? So using Python library, using NiFi. So we have seen this, right? And after that we have seen data processing tool or data processing service called data proc, right? So in here we have discussed how to write PySpark code, what is Spark, right? And how to develop a PySpark application, and how to write the processing logics in PySpark, and how to deploy that application to GCP data proc cluster, right? How to create clusters. So all these things we have discussed, and we have seen Spark configurations, how to define Spark configurations, how to create Spark sessions. All these things we have seen, right? And we have seen RDD based programming. We have seen data frame based programming, right? And finally we have also discussed about BigQuery, right? So BigQuery as a data warehousing or a data storage or data loading service, right? So we have seen a BigQuery as well. So we know how to create tables in BigQuery. We know how to load data to BigQuery, right? And we know how to load data from GCS to BigQuery. From Python, we have loaded. From Dataproc, we have loaded, right? So we have seen the tight integration between these three services, right? And we have seen stored procedures in BigQuery, right? So we have covered three major services that are required for data engineering. Okay, so one is a raw layer, okay, where we ingest data files from external source systems, and then the processing layer where we read the data from GCS and then process it, aggregate, and then load it into BigQuery. Okay, now, okay, so we have the raw zone, and then we have processed it in Dataproc, and then we have loaded to BigQuery. Fine. So now, how actually we can automate this process? So how we can automate this process? We need triggers, right? When to trigger data proc job, when to trigger BigQuery stored procedure, right? So we need a few triggers, or we need some kind of uh, uh, pre-logic that needs to be executed, right? So before triggering the data proc job, we need to know which table that we are processing, or we need to know which table that we need to load, right? So some kind of pre-processings that we need to do before data proc, or some kind of triggers that we need to actually trigger the data proc job, or to trigger the BigQuery proc, right? So some event based triggers that we call it as in Google Cloud Platform, we have event based triggers. Okay, event based triggers. So those event based triggers are you can say that cloud functions, PubSub, and then cloud scheduler. So let me quickly cover these three services. These are very small services only. They won't need much of your time, but I want to cover them all so that you will be aware that how we will trigger these jobs, right? So there is a service called Cloud Function. Okay, and then similarly there is a service called Workflows. Okay, Cloud Workflows. And then there is a service called Cloud Scheduler. Okay. Now let us understand the importance of these services. Okay. Now cloud functions. So cloud functions are very lightweight, serverless executable services. Meaning, if you have a cloud function created that is a serverless, you don't need to define any kind of a compute as such. But for this cloud function, you can enable the trigger. Let us take an example. As and when a file got uploaded into the GCS bucket, I want to trigger a cloud function. In that cloud function, I want to do some pre-processing, or I want to trigger my data proc job from the cloud function. Okay, I want to trigger my data proc job from the cloud function. So some kind of a logic you can put, some kind of a Python logic that you can put. Okay, let us simply understand how we can use this cloud functions. Okay, I'll give you a real time use case so that you'll try to understand how we can uh, implement these cloud functions in real time. Okay, so let's understand the high level importance of each and every service so that we can see example, and then we can wrap these services. Okay, you can still go ahead and practice multiple use cases. I'll give you those use cases as well, but you need to understand the high level importance of each and every service. Okay, now let us see the cloud functions. Okay, so when you say cloud functions, just give me a minute. Just give me a minute. I think I've prepared some content. Yeah, okay. I got it. See here. So cloud functions. So what are cloud functions? These are event-driven execution. So this is the first feature of your cloud function. Okay. So meaning what? If I uploaded if I ingest a file into GCS, immediately my processing should trigger. Okay. Now what will happen if you create a cloud function and enable GCS storage trigger? So that cloud function will execute as and when the file comes into the GCS. So it's a event driven. Be very clear. It's a event driven. So what are all the events that you can enable? You can enable a event trigger from the GCS, or you can enable a PubSub trigger. So that is a different concept. I'll come to that later. But for now, you understand these cloud functions are very lightweight executable service, which is actually a serverless service. And then these are event-driven execution services, meaning based on a event, you can trigger cloud function. Okay, you can generate a event automatically by placing a file or by ingesting a message into the PubSub, whatever it is. So you can trigger them based on a event. Okay, that is one of its feature. And serverless, there is no infrastructure related things that you need to take care. So that is one other advantage. And then it will support multiple languages. You can write your processing or pre-processing lightweight logic in Python, Java, or Node.js, right? So all these languages it will support. Even Go language also it will support. Okay, so your in your cloud function you can write your processing logic. Okay, you can write your processing logic. So it is not like Dataproc. You can write your Python processing logic. Okay, so that kind of a lightweight pre-processing things you can do. Let us take an example. You uploaded a file into GCS, and you need to check the file naming convention. And based on the file name, you need to trigger the Dataproc job. Okay, for example, if the file name consists of EMP, then you need to trigger the EMP table load. If the file name consists of department, then you need to trigger the department table. So but your wheel file is same, so you have all the logic in the same project code. Your wheel file is same. So what will happen, you need to derive that flag or identifier before in hand, so that you can pass it as an argument to your data proc job. So in that scenarios, your cloud functions are really helpful to do the pre-processing, to do the to apply pre-logics required for your data proc jobs. Okay, I'll give you a real-time use case. You don't need to worry. Okay, so now and then these integration with other GCP services. This is very tightly integrated with all the GCP services. So cloud functions are tightly integrated with GCS, PubSub, Dataproc, BigQuery, any service you take. So you can integrate this cloud function, even workflows. So you can integrate this lightweight functions. So this is a very simple service, guys. So don't confuse much. You can write your simple Python code and then trigger that Python code based on the events. That's the core intention of this service. Be very clear. Okay, don't get confused. This is a service which is serverless, where you can keep your Python code, okay, and then trigger that Python code based on a event. Okay, what is the event here? Let us say you placed a file in GCS, that will generate an event. Okay, so that is one event. Let us say you pushed a message to the PubSub, that is one event. So these events are the triggers for your cloud function service. Be very clear. Okay, so you can call your cloud function from workflow. You can call the cloud function from any kind of other service also. But remember, these cloud functions are very lightweight. Okay, very lightweight. You cannot use cloud functions for huge data processing. You cannot use cloud functions for very large scale processing. These are very lightweight. Be very clear. Okay, these hardly these cloud functions will run for for some time only, meaning 10 minutes or 9 minutes. In Gen 1 there is a limitation on time. Your cloud function can only run up to 9 minutes. Okay, so you just need to use these cloud functions as your pre-processing services, meaning, so your cloud function only derives some pre-processing logics that are required and run the logics in other services, just as a trigger. Okay, now let us see a real-time use case which is actually on cloud functions, right? So let me explain you the use case, right? So I have my NiFi. Okay, I have, okay, and this NiFi is continuously ingesting data into my GCS. Okay, so continuously ingesting data into my GCS in with respect to the date wise folders. Let us take an example. I have directory structure like this: raw data, or else bucket, slash raw data slash table name slash date slash the parquet files for the day. Okay. So your NiFi is continuously running, and it is for every half an hour your NiFi interval got scheduled, your NiFi pipeline got scheduled for every half an hour, and then immediately your NiFi is communicating with multiple different source systems. Okay, multiple different source systems, like you have Oracle or SQL Server or any other databases, and then it is communicating with those databases for every half an hour and getting the data from those systems. Okay, and then it is ingesting it to GCS. Okay, guys, till now are we clear? So you have a NiFi pipeline, which is actually the data ingestion pipeline, which will be ingesting data from Oracle or SQL Server and load it to this particular directory in GCS. Okay. And for every half an hour, your NiFi pipeline will run, or on a daily basis, per day, one time your NiFi pipeline will trigger. It will go and ingest the data into your GCS for that particular day. Okay. Are we clear, guys? This till now we are clear.
Yes.
Okay. So once it ingests the data, we need to track the ingestion status, right? We need to track the ingestion status, right? And we also need to maintain our last load timestamp or last loaded date, right? So for that we will maintain a control table. Remember, we maintain a control table. Okay. Now in this control table, what we will happen? So what we will store? We will store, table name, and then last load time, right? Ingestion status, last run date, right? So we will store all this metadata, right? So for every table that NiFi is ingesting, so you can actually track the status of the ingestion from this table. Okay. So what will happen? So every day NiFi will pull the data and then ingest it into the GCS, and it will update the record in the control table for that particular table. Okay. So that will also be in the NiFi only. Using the execute SQL processor, we can go and update it in the control table. Okay. So now from here only it will take the last run before running the pipeline. So it will take the last run and then last run date, and then it will apply the SQL on top of these sources accordingly, and then it will pull the data. Okay, fine. Till now we are good. Okay, so the ingestion is happening continuously into our GCS, and then your NiFi pipeline is updating this control table for better tracking. Okay. Now the next thing is you have written a PySpark framework. Okay, you have written a PySpark framework, which will consist of all the 100 tables processing logic. Okay, all the 100 tables processing logic. You have 100 tables that are being ingested by NiFi from these two source systems. Okay. Now, what you need to do you need to segregate these 100 tables into different groups. Okay, different groups, meaning in the first group, group 1, you have 50 tables. These 50 tables are one to one, meaning whatever the data that is present in the source system, we need to load as is. Okay. Now another 10 tables. Let us take an example. You have 60 tables logic. Okay, you have 60 tables logic, and then here you are ingesting 100 tables. Okay, here you are ingesting 100 tables. Now in the group 1 you have 50 tables which are for out of this 100 tables, 50 tables are one to one mapping. So one to one mapping is there is no processing required. Okay, we just need to add some columns like run date and system insert date and all, and then we need to load it. Okay, that's it. And remaining 10 tables, let us take an example. Here you have 10 tables. So your 100 tables are becoming 60 tables in your target system. Okay, so that means in your big query, you have 60 tables. Okay, you have 60 tables. Okay, and in this 10 tables, I have again group 2, group 3. In group 2, I need to load 5 tables. And then I have group 3, I need to load 5 tables. Okay. So group 2, I need to load 5 tables. And then group 3, I need to load 5 tables. Now, what are these 5 tables? These 5 tables logic got derived by the remaining 50 tables that are present here, right? So we are just doing a lot of transformations on the remaining 50 tables, and we are finally generating 5 tables in the BigQuery. Okay. Now, once this group 2 got triggered, after group 2 only group 3 should trigger. Okay. Follow me, guys. This is very important real-time use case. Okay. So after group 2 only, our group 3 should trigger. In group 3, we have 5 tables. Okay. So now your entire 100 tables become 60 tables. Out of 60, 50 are one to one. 10 tables are transformed tables or aggregated tables. And these 10 tables are dependent on the remaining 50 tables from the source. Okay, and these 10 tables has been segregated into groups, group 1 and group 2, group 2 and group 3, and there is a dependency between these groups, meaning first group 1 should trigger, and then group 2 should trigger, and then group 3. Okay, now in this thing also, your PySpark framework has designed in such a way that it will take table name as an example. That's it. Sorry, table name as an argument. Okay, table name as an argument to your PySpark job. Okay, so what are the arguments for your PySpark job? Let us quickly understand that thing. So you have a PySpark framework, correct? In this PySpark framework, you have created your entire processing logic like this, right? Like a project we have created, and in the main, you have two arguments here, right? So which table that I'm planning to load, and for which date I'm loading, right? So these are the two things it is going to accept. So table name as an argument, and then run date, for which date you need to trigger or you need to run the processing logic, right? So these are the two arguments. Now I have my files that are creating in GCS, and I want to invoke or I want to trigger my processing logic daily once. Okay, I want to trigger my processing logic daily once. Okay. Now, how I will schedule my job? So that's where you have a service called Cloud Scheduler. You have a service called Cloud Scheduler. If you want to schedule your GCP jobs or Google Cloud jobs, Dataproc jobs or BigQuery jobs or Cloud Run jobs or any other jobs or even a cloud function, if you want to schedule, then you can use this Cloud Scheduler. There is a service called Cloud Scheduler which will schedule your jobs based on a time zone. Okay, let us take an example. Every day 10 a.m. I want to trigger a job. Okay, so then you can go and schedule your job in the Cloud Scheduler, and then that will run automatically. You don't need to, no manual intervention needed. That is the high level purpose of your Cloud Scheduler, and it's a serverless. Okay. Now, okay, so I have scheduled my job, or else let us take an example. I have scheduled, or I want to go with the event-driven approach. Okay, so my use case is event-driven. As and when NiFi ingests a Parquet file for that specific day for that table, then what I need to do, I want to invoke my data proc job by passing these two arguments, right? So these two arguments I can derive it from the path. I don't know, my data proc job don't know which path got created in the GCS, right? So that is where I will enable event driven cloud function. In this cloud function, I will read as and when this Parquet file got created in this bucket, right? I can trigger my cloud function, and this cloud function can get the event metadata. Event metadata. So, what is the event and why it got generated, right? And what is the file that got created? I can get that information in this event metadata to my cloud function. Okay. Once I have this event metadata, from this event metadata, I will extract the path which file got created in the GCS. Then from this file path, I can extract the table name. And then from this same file path, I can extract the date, run date, for which date I got the files, right? I will do that pre-processing here in the cloud function, and then I will trigger my PySpark submit here. Whatever the command that we have, right? So we have this command, right? Gcloud dataproc job submit, and I will pass the derived variables from the cloud function. So as and when this got triggered to dataproc, your cloud function job is completed. It is just a trigger. Okay, it won't monitor your entire dataproc job. Be very very clear. Okay, be very very clear. And your cloud function, your data proc, as and when your submit happens, that's where your cloud function and your data proc connectivity will end. Your job has been submitted, that's it. I don't need to do anything else. Once it got submitted, then we need to trigger the BigQuery stored proc. Okay, so this is a sequence, right? So this is a sequence. So wherein you first need to trigger a cloud function, and that cloud function uh, needs to pull the data for that particular run date, and then trigger it, trigger a processing logic, and then a stored proc. So this is a sequence that you need to run, and everything is scheduled on Cloud Scheduler, right? So your Cloud Scheduler will run your cloud function on a specific time also, right? But you can also enable the event trigger. Okay, so now the approach that we have seen is event based trigger. So on a specific event that got created, we can trigger the cloud function. Okay, let us take an example. 100 files got created, 100 cloud functions will get created automatically. 100 files got created. This cloud function will scale automatically to your 100 files. Okay, so that is how the same cloud function will be called 100 times. That's the logic here. You create a cloud function on GCS bucket. So what will happen, as and when the file got ingested. Okay, so as and when the file got ingested into GCS, so you can execute your cloud function, but you don't have the control on entire orchestration, right? So this is event-driven approach. Okay, event-based. If we trigger, so wherever we want to trigger event-based, we can trigger. It's not like we don't go for this approach, but in a typical data pipeline, if we want to go for this approach, we may lose control on the pipeline, processing control on the pipeline. So that is where the orchestration services come into the picture. Okay, that is where the orchestration services come into the picture. So we have different um, service altogether for orchestration. Orchestration meaning, first which job needs to be run, second which job, third which job. So you can create a flow, a data flow, right, by using this orchestration services. That kind of orchestration service in GCP is workflows. Okay, Google Cloud workflows. So by using workflows, what you can do, you can actually so meaning, first you need to execute a cloud function, and then you need to execute a data proc job, and then you need to execute a BigQuery stored procedure. So execute the cloud function, get the results into the variables, and then pass the variables into the data proc job, and then execute the data proc job, get the status of the data proc job. Based on the status, call another data proc job or call another cloud function. So this kind of orchestration, data flow orchestration, you can do. Orchestration meaning arrangement. Okay, orchestration meaning arrangement of your pipeline, right? So that is something you can do with workflows. Okay, so this is the high level importance I'm explaining. We'll see the practical examples also, don't worry. But the high level importance of your cloud functions and cloud workflows and cloud scheduler, you need to know. Okay, cloud scheduler to schedule your jobs. Okay, for a typical time, if you want to trigger your jobs, you can use cloud scheduler. Cloud functions are lightweight serverless execution, event driven uh, execution functions. Okay, you can use them for pre-processing. Okay, pre-processing meaning to derive the logics that are required for your workflows. Okay, so and similarly orchestration, so the arrangement of services, right? So meaning, if you want to arrange all your GCP services one after other, or if you want to create any dependency, then you can create that kind of a data pipeline. We call it as a pipeline, right? So that pipeline in workflows. Okay, so now let us see one more real-time use case using workflows, right? So for workflows, where we can actually go for workflows. So this everybody clear, event driven cloud function execution. And then after that cloud function, from the cloud function we are triggering the PySpark job. Okay, and in the PySpark job itself we are triggering the BigQuery stored proc. Okay, so this is a one kind of a pipeline. Okay, guys, are you clear? This is one of the real time use case that you need to know. Are you guys clear, guys? Any questions you can ask?
Yeah, clear.
Yeah, clear.
Okay, fine. So now let us go and see one more use case, the same use case only. Okay. Now, simple. I'll only do a query-based pipeline now. I will eliminate NiFi. So till now it is same. Okay, till now it is same. You have the control table, you have the GCS and NiFi sources, everything same. Now in GCP, you just observe how actually I'm trying to build the pipeline. Okay, so there will be a cloud scheduler. Okay, now the time I have set is every day once I want to trigger my pipeline, right? Every day once I want to trigger my pipeline. So I will try to trigger the pipeline. Okay, let us take an example. 11:59 p.m. night. Okay, 11:59 p.m. So I'm expecting by this time the GCS file got created. Okay, now I have my cloud scheduler will start executing the process. Okay, now I have created a workflow in such a way that, so this is my workflow. Okay, in this workflow, what I have, let us quickly understand simply. So I have a cloud function. I have a cloud function, and this cloud function, after the cloud function, I have a data proc job. Okay, and after this data proc job, based on the status, based on the status, okay, let us say this data proc job got failed. Then it, if it fails, it has to go and execute another cloud function. Okay, if it got succeeded, if it got succeeded, then what it needs to execute, it needs to execute a BigQuery stored procedure. Okay, to do the merge or to apply SCD rules like merge operation or append operation. So whatever the load, right, from stage table to target table, if you want to trigger. So assume your data proc job is loading the data into a stage table, and then from there to target table, you are calling a BigQuery stored proc. Okay, so if your data proc job got succeeded, then you will call a BigQuery stored proc. Now what will happen, you created them once the BigQuery stored proc got completed. Okay, once the BigQuery stored proc got completed, then what you need to do, you need to call another cloud function to update the status. Okay, here cloud function 2 only you will call with different status as succeeded or success. Here the status as failed.
Failed.
You will call the same cloud function with different arguments, or else with the different thing altogether. Okay, so here if you see, this is the pipeline, right? This see the proper arrangement of your code, of your different components in your entire thing. Now how my cloud function will know for which day I need to go and extract the files. So your cloud scheduler has already triggered, right? So then what will happen immediately, your cloud function, your cloud function will go and fetch the data from your watermark table. Be very, very clear. Okay. From the watermark table, it will go and then fetch the record or tables that are there for that particular day. Okay, what are all the tables that are there for that particular day? It will go and fetch all the tables data. Okay, now what will happen? It has to pass the tables list or paths list. It will return the paths list from the cloud function. Okay, okay, so this is the cloud function. So in your workflow, you can pretty well create loops. You can pretty well create variables also. So you can assign this cloud function result to a variable, and then you can apply a for loop in this workflow only. Okay, and call your data proc job inside the for loop. So every table it will load in a sequential fashion, and then based on the dependency you can actually load group wise also. Okay, and then entire pipeline will follow the process. So here if you see the proper arrangement happens, right? But in the event driven it won't happen, so you lost the control here, right? So that is the reason majority of the times we'll go with the proper orchestration services. Okay, proper orchestration services. So remember, so you need a trigger, right? For this workflow every day you need it, I mean trigger. So this entire workflow has to be triggered once in a day. So that trigger is your cloud scheduler. Your cloud scheduler will trigger your workflow. Your cloud scheduler will trigger your workflow every day. So here it is your workflow. So this entire thing is your workflow pipeline. So how we create it, we will see. Don't worry. But theoretically, try to understand the purpose. That is very important, guys. So technically, yes, everybody can do the process. Okay, you can learn things from the Google, or I'll give you one example. You will try another example. It will come. But the purpose you need to understand. Okay, why we need this service and where we need this service in GCP. What is a use case where we can apply this service? So that is something that you need to understand. So we have seen a use case for cloud function, and we have seen a use case for scheduler and workflow pipeline. Any questions or queries, guys, in this two use cases? I need your inputs. Otherwise, I won't be able to get confidence on these two. So any questions or queries, guys?
No.
Bablu, Prakati, Anusha.
No, Venkat.
Yeah, Venkat, clear.
Okay, fine. So let's quickly go and see how we can create a cloud function. Okay, how we can create a cloud function. So simple, guys. So here, if you see, you can go and type cloud function, right? So here, if you see cloud run functions, you have, right? So you just simply go here. Previously, it is cloud functions, but in the recent updates, they have renamed the cloud functions to cloud run functions. Okay, so fine. So simply you just need to create a function. So here, if you see, I have created a function here called test. Okay, so this is my cloud function. So let me get. Okay, fine. So let's see how to create a function, right? So just simply go here and create the function. So here, if you see my function name, so I'm just saying testing. Okay, CF cloud function. Okay, so here you see the triggers, right? This is the important part. You can select your trigger. So okay, so I want to select my cloud storage trigger. Okay, meaning I want to select my GCS trigger. So here I'm just selecting it. Okay, So on which bucket I want to select my trigger. So I want to give the bucket, right? So here, if you see, the training default. Okay, just select it. Okay, I have selected my bucket. Okay, and here you have different options also are there, so you can provide all the different options, retry on failure, all these things. But for now I don't need all those things. So here, if you see, you have given the cloud function name and selected the trigger for your cloud function, right? So you selected the trigger. So you can trigger your cloud function from a http request. You can trigger your cloud function from a pub sub message, right? You can trigger file store. This is a different service, we don't use this. Okay, but pub sub and storage, so these two we definitely use in our projects. Okay, so pub sub meaning, so this is a message queue topic. We'll discuss that tomorrow. But for now, try to understand the storage-based trigger. So we selected the storage-based trigger, and then next is the code. Okay, what you want to execute. Okay, so you enabled a file based trigger in GCS bucket. Okay, once the file got arrived, then what is the logic that needs to be executed? So you have to keep that here. Okay, now let us see. I'm just selecting my language as Python. Okay, so I'm just selecting my language as Python. So here, if you see, main.py, this is your core logic file. So in your cloud function, you need to create a main.py file and requirements.txt. So this is some external libraries. Let us say you need pandas, or you need numpy, or you need third party Python libraries. Then you can specify them in this file, requirements.txt file. Then it will install these libraries first, and then it will run your code. Okay, so that is the importance of your requirements.txt file. You have main.py file and requirements.txt file. So these two files are very important in cloud function. Okay, so when you are creating cloud function, you need to have these two files. Be very clear. Okay, so now here, if you see, you have functions framework or something, right? And then you have hello GCS. So this is your function, and the input for this function is cloud event. Okay, cloud event. So as and when the file got created in the GCS, so that entire metadata is the input for your function. Okay, now from that event, you can extract all the metadata, and I'm just printing that metadata. That's it. Okay, I'm just printing that metadata. Fine. So here, if you see, I'm just simply going and deploying this. Okay, I'm just simply going on deploying this. So what will happen? So it will go and deploy this cloud function, and it will be continuously running in your GCP project. Okay, it will be continuously running in your GCP project. And there is other way also to create your cloud functions. Okay, because it's a development project or a free project, we were able to create that from the UI. But if it is a production projects, right, or else if it is any kind of test related projects, you don't get access to create cloud functions from the user interface, meaning from the UI you won't be able to do that. In development projects only you can create your cloud function from the UI. In test and production projects, you need to use the command line from your Vertex AI notebook. So see here, create a cloud function from the command line. G-Cloud functions deploy the function name and the runtime. So Python environment runtime and the trigger event, right? So here Google Cloud Storage object finalize, meaning whenever the object got created, then trigger the event. Trigger source, the bucket name, you need to and then entry point, the main dot py, or main, you need to specify, and then region, region name, source, the path to your cloud function, right? So this is how you can execute using the command line. Okay, we will see that tomorrow. Pub sub and the command line based execution, we'll see that tomorrow. But just try to understand how this cloud function got created successfully. Okay, so now let's simply upload a file. So here, if you go to logs, you don't have anything, right? So let's see the logs here. So you can see the logs of your cloud function. So there is nothing here, right? So now what we need to do, let's simply upload a file into GCS. Okay, so let's simply upload a file into GCS, so that we can check whether our cloud function is running properly or not, right? Okay, so this is my bucket, the where I actually enabled my cloud function, right? So let me go into the bucket, and then I'm going into my VRI directory, and I'm just uploading my file from my local system. Okay, here I'm just uploading my test data.csv. I don't know what's happening. Upload started, it is saying, but where is that file? Let's go into the buckets again, and then my bucket, and then okay, so the file got uploaded. So let's go into the VRA. Yeah, here if you see test data csv.csv, this is a file that got created in the GCS, right? So if you simply go and see the logs of your cloud function, see here, all your print statement got printed in the log as and when you got uploaded, right? As and when you got uploaded, see here, the file path also you got, right? That means your cloud function picked that event automatically, and you can tweak that metadata and then use it according to your requirement, project requirement, right? So this is an event, right? So as and when you upload a file into GCS, your cloud function started detecting that file and then giving you the metadata. So by using that, you can do the further processing. Okay, by using that, you can actually do the further processing. Okay, any
It's a
questions?
bucket wise. It's a bucket wise event, right? Like you have selected the bucket, default bucket, and then you applied the cloud function. So wherever in that inside that bucket, if you upload a file, that will pick up automatically, right?
Yes, correct.
Not only
So
in
if
Viroi.
we, oh yeah, not only Purell, correct.
Okay.
Any directory it will automatically pick, but in a project we may be having segregations, right? So sometimes we may need to read files from a specific directory. If any file got uploaded in one directory and suddenly this cloud function needs to be executed, then what you need to do, you need to apply the regular expression filter on your paths, that your event is generating. Then, according to that regex, you need to filter the paths first and then process only the required paths. Okay. So let us take an example. You have a directory called raw data. Okay. And then you have stage data, and then you have target data. Three directories are there. But you want to process only the files that are coming to raw data, right? So in the path, you need to match your string. So if your path have raw data string, then only you proceed further. If not, then just simply leave it.
Okay. Okay.
Okay. Guys, clear?
Yeah.
Guys, everybody clear on cloud functions, right? So we have seen a simple example on cloud function. Okay. So we created the cloud function, and then we just uploaded the file into GCS. So we have seen the event-based cloud function, right? So tomorrow we will see the PubSub-based trigger. So what is a PubSub? Where we will use the PubSub service. So we will see the PubSub-based trigger to the cloud function. Along with that, we will also trigger the cloud function from the workflow. Okay. So collaboratively, we need to see all the services. So most of the things, workflow, and then cloud scheduler, and then PubSub. These three services I will try to cover tomorrow along with this cloud function integration. Okay, so I will place the cloud function in the workflow, and then I will enable the PubSub trigger, and then I will schedule that in the cloud scheduler. So these two use cases we are going to see tomorrow. So don't miss the tomorrow session. It is very important. Okay. And on Sunday, I will take a couple of hours to go with the project, real-time project explanation. Okay. So real-time project explanation. So that's where we will conclude our training sessions. Okay. So I think in that session, in that session itself, I will try to share the resume with you. So I will my resume with you, so you can actually prepare your resume and then upload it into your portal so that you can get calls on data engineering, cloud data engineering, right? So that is the end of our sessions. So Sunday, I'm planning to close the sessions. Okay. So and in these services, cloud functions, workflows, and cloud schedulers, and then Dataproc, BigQuery, GCS. See how many services you have, right? So these services you need to keep in your resume. Okay, I have worked in a data engineering project wherein we used all these services collaboratively to build our data pipelines. So this is how you need to project your self in the market. So then only you will get calls. Okay, if you keep only GCS on Dataproc, no, you don't get any calls. Then immediately you will get questions. So how actually you orchestrated your data pipeline? So how actually you integrated your Dataproc to BigQuery? So you'll get a lot of questions. So you need to be aware of all the services that we discussed now. Okay. And in the real-time project execution, project explanation, I will give you a end-to-end project use case. Okay, end-to-end project use case, and I will explain you how to implement it in GCP. Okay, but you have to do a POC on that project. Then only you will get the complete understanding. Okay, so till now we have worked on multiple different tasks. Okay, combinedly I will give the project use case, be very very clear. Okay, so on Sunday the module that we are going to discuss is very important. It is a real time project implementation, how actually we will implement a project, but you guys have to implement it. I will only explain how a real time project implementation will be done. Okay, on a presentation, or I will take a PPT, I will explain step by step. But it's you who have to take this and then implement the entire architecture, okay, in all the services that you have learned. Okay, this is the thing that you need to do. Okay, so that's all I have for today, guys. And one more last update that I have is about the course payment. Okay, so few people have paid half of the amount in the beginning of the session, like 3 months back. So there are a few payment pendings, okay, from I request everybody to complete the payment by tomorrow, end of the day, right? So that we can, we can clear everything, right? So that's all I have for today, guys. Thank you so much for joining. We'll connect back on tomorrow once again. Yeah.
Thank you.